So it is convergent for n equal to n greater than 1. If n is greater than 1, then this function is convergent. Or this kind of algebraic functions, if I take dx upon x square, dx upon x cube, dx upon x4, okay, if n is greater than 1, then the function will be convergent. So we will directly write that this function is convergent. Okay, now let me take second question. So for the second question here, okay, now question number second, is it convergent or divergent, that we have to prove here. Second question says test the convergence of the integral this. Okay, now let me solve this question. Let me change the mark. Okay, so second question here, this one, test the convergence of integral of 0 to infinity, that we write it. So this is second question here. We have to test the 0 to infinity e raised power minus x into dx. Okay, so let me solve it. Now in this question, if I write this question in two terms, let me take 0 to 1, okay, and e raised power minus x plus 1 to infinity. Okay, now in this case, this function is e raised power minus x into dx. Now what about this limit here? This is now finite limits. First function is finite, so it is convergent, or its integration will be e raised power minus x upon minus 1. Okay, 0 to 1 limits plus 1 to infinity e raised power minus x into dx. Now if this is convergent, this will also be convergent with integration. Now within this limit 1 to infinity, if I take positive value, there is 1 to infinity, function will be convergent. The first part is convergent here. So the first part, okay, in the first part, or let me write here, in the first part, this first integral, this is I1 suppose, and this is I2. I1 is convergent. In the first part, okay, 0 to 1 e raised power minus x into dx. Limits are finite. Limits are finite, and this function is also finite, and the function is bounded, or the integrand. Let me take function is integrand in this case. Integrand is bounded, or its limits exist. Why? Because if I put here 1, it will be e raised power minus 1 only. So 1 upon e exists. Okay, at 0 also it is 1, so it is plus sign, then 1 plus 1. If I take this is 0 here, it is 0, so 1 plus 1. Okay, so if first function is finite limits are there, which is exist, this will also exist here. Integrand is bounded. So by comparison test, let me write here. So by comparison test, suppose this is f2x, this is f1x. Now this f2x and f1x, these functions are, f1x is convergent, f2x is also convergent. So by comparison test, let me take. So by comparison test, f1x, let me take this, f2x is convergent. F2x is convergent if f1x is convergent. If f1x is convergent or is convergent. Here f1x is convergent because it is definite integral, finite limits are there. This is convergent, this is also convergent. So this function is convergent here. Okay, e raised power x, which one? Second question, 0 to infinity e raised power minus x is convergent here. This function is convergent. So second question is convergent by comparison test. We write here it is into two parts. First part is if any part is convergent, and second is also convergent. Now let me talk about third question. Now test the convergence of the integral this. Okay. Now question third, let me take how it oscillates. Okay, this function is a to infinity. This is cos x dx. Now integration of this will be cos x sin x here. Okay, integration. This is a to infinity. So this will, if I take limit x tend to, let me take limit x tend to infinity, and this is x here. Or if I take epsilon here, let me take epsilon. This is 1 upon epsilon, and this is limit epsilon tends to 0 equal to epsilon tends to 0 sin x e to 1 upon epsilon. Now putting the limits here, it will give us sin x minus sin a. Okay, limit x tends to infinity. Sorry, this epsilon tends to infinity. Epsilon tends to infinity. Epsilon tends to 0. Sorry, epsilon tends to 0 and limits 0 to a2 is a. I substitute here. Here in this case, this will oscillate. This is greater or equal to 2. I'm sorry, this is less or equal to 2. Is less or equal to 2 here. So this may be a suppose is positive value, and a sin a is positive. A lies between plus 1 and 1 is less or equal to 1 negative value. This can also be negative. Okay, so when negative values, it may be sometimes 0, but it maximum value is less or equal to 2. Okay, so this value oscillates. Hence, a given integral, a given improper integral oscillates. Okay, oscillates. So this is oscillates. It does not. When a function is oscillates, sometimes its value is is going to exist, and sometimes it is not existing. So within this limits, sin x, if x tend to infinity, x tend to epsilon tend to 0 here. If I put here epsilon 1 upon epsilon, suppose this is x here 1 upon epsilon, because limit we have to substitute here 1 upon epsilon. So it is infinity. In that situation, it is not exist, but the sin a exists. So it is oscillating. So integral oscillates. When the limits oscillates, let me define this. When the function is said to be, oscillating, not converging, not diverging. Okay, when the function or integrand, when the integrand is said to be oscillatory, Okay, if the integrand exists or does not exist, if both happens, or both these situations happens, if both these situations happens, or situations happen within the given limits, then function said to be oscillatory. Okay, within the limits, then the function is oscillatory. So this function in this case is oscillatory. Okay, because it's not converging, not diverging. Sometimes it is converging, sometimes it is at one point it is converging, at another point within the same limit it is diverging. Function is not convergent or divergent, but oscillatory. Okay. Now let me take fourth question. Now in this case, question number fourth here. Let me talk about. Now question number fourth, what does it say? It says test the convergence of minus infinity to 0 e raised power x into dx. Okay. Now in this case, let me take this function extend to minus infinity if it is x to 0. Okay. In this situation, the function is oscillatory or convergent. Let me integrate this function. Its value will be e raised power x within limits minus infinity to 0. Okay, or if I take epsilon tends to minus infinity, epsilon to 0. Okay, so that can also be done. This is equal to e raised power 0 means 1 and minus 0. Minus sign, this is e raised power infinity or minus infinity, that means 0. This is 1 minus 0. It adjusts equal to 1. Hence, the function given, this is adjusting. This is convergence. Hence, the given function is convergent. Hence, the given function is convergent. And the given function is convergent. Okay, so this is convergent. Why? Because the value is equal to 1. It exists. The function is bounded within the given limits. The function is, okay, this is known as convergent function. Here the limits are convergent and the function is convergent. Let me now talk about fifth question. What is question number 5 say? Let me check it. Okay, so let me check the question number 5 here. Question number 5, test the convergence of minus infinity to plus infinity. Okay, this is minus infinity to plus infinity. This is dx divided by 1 plus x squared. Okay, now if I take this by comparison test, or let me integrate this, it will be, it can be written as 0 to infinity, because this is minus a to plus a limits by definite integral. This we know about. This is 1 plus x squared. What about this? This is twice integration of this will be tan inverse x. Tan inverse x limits 0 to infinity. What about this? This is twice into, what is integration limits tan infinity, sorry, tan infinite lies, and this is tan inverse 0. This is pi by 2, twice into pi by 2 minus 0. This is pi only. To exist, it means function is convergent. This is convergent here. So answer is, so the function is convergent because this is existing. The limit exists. The limit, so the limit exists. Limit, so the limits exist, and the value of the function, the convergence function, it converges to pi, and the value of the function of the converging, it converges to pi. Value of the function of convergence is equal to pi, or you may say the function exists within the given limits. That means it is convergent function. So it is convergent here. Now let me talk about next question number 6 here. What does question number 6 say? Now question number 6. What does it say? It says test the convergence of this. Okay, now here we have to apply comparison test. This is dx upon x squared under root 1 plus x squared. If I take, let me take limits 1 upon x squared under root 1 plus x squared. Okay, this is, we know that this is less or equal to, less than 1 upon x cube. Why 1 upon x cube? Because this is x square, and 1 upon x is, suppose this is less than or equal to this one. Here, okay, a to infinity 1 upon x cube dx is convergent. Why? Because x is here and is greater than here. From first question, here n is, let me write here, since n is equal to 3, okay, greater than 1, which is greater than 1. Naturally greater than 1, it is not equal to 1, but greater than 1. Therefore, this is convergent function. Hence, this f2x, this is f2, suppose this is f1, this is f2, or this is f2, this is f1. Here f1 is, so this is convergent. So, this is convergent, okay, hence, given function, hence the given function is also convergent, by comparison test of convergence. Why? Because we have taken this as f2x. F2x is this function. This is f1x. Now here f2x is said to be convergent if f1x is convergent. But now we know that 1 upon x cube, limits a to infinity 1 upon x cube is convergent, but here n is greater than 1. If it is 1, then it cannot be convergent. Okay, if 1 upon x is there, let me define this. So this is convergent here. Why 1 upon x is not convergent? Let me talk about that. Okay, limit a to infinity. If it is 1 upon x only, integration will be log x. And if I put the limits a to infinity, we log infinity first one minus log of a. This is equal to infinity because this is infinity. Infinity plus something is infinity, so it does not exist. For n equal to 1, so for n equal to 1, it does not exist. Or it is divergent. It does not exist. It does not exist. The function is does not exist. Function is divergent in case of x equal to n equal to 1. 1 upon x if n is equal to 1 in first case. But in this case, this function is, we know that this is, if I compare this with 1 upon x cube, and x cube means x n is equal to 3. For that function is convergent. That is convergent, this is also convergent by comparison test. By comparative test or comparison test of convergence, this function is convergent here. Okay, this is not convergent here. Now let me talk about 7th question. What does 7th question say? Let me talk about that. Now what is question 7th? Okay, now question 7, test the convergence of integral, this one. Okay, so here, question number 7, test the convergence of a to infinity, this is cos x upon 1 plus x square into dx. Now here, cos x is, okay, now let me take by comparison test. Let cos x upon 1 plus x square, this is less than or equal to, sorry, this is 1 upon x square, 1 upon 1 plus x square. Now here, modulus of cos x is oscillatory, okay, but this function 1 upon 1 plus x square is convergent here. Okay, this is convergent, this is also convergent, and here f2x is equal to this value cos x upon 1 plus x square, and f1x is 1 upon 1 plus x square. But integration sign a to infinity 1 upon 1 plus x square is equal to, this is convergent, is tan inverse x limits a to infinity. So this will be tan infinity minus tan inverse a. Okay, now this tan inverse infinity is it a to infinity? Which question it is? Or 0 to infinity, I'm sorry. Seventh question is 0, I'm sorry. It is 0 to infinity here. So 0, a is not a, but it is 0 to infinity. In seventh question, limits are 0 to infinity. Cos x upon 1 plus x square. Now if I take f1x is 1 plus x square, so I'm talking about 1 plus x square first. Now this function is integrable, or is its limits is limit exists. This is pi by 2. This is tan inverse 0 is 0 here. It is equal to pi by 2. The limit exists, that means this function is convergent. Hence f1x is convergent. f1x equal to 1 upon 1 plus x square with Bessel limits 0 to infinity into dx, limits 0 to infinity dx exist or is convergent or is convergent or is convergent. If we a comparison test, this is also convergent. Okay, so this function given is convergent here. So this is how we define that this is also convergent. And by comparison test, we can say, hence by comparison test, this is convergent. This is convergent. This is a convergent function. This is a convergent function or integrand. Okay, so convergent function or integrand. So this integrand is, this integral is convergent. This is what question number 7 is. Now let me talk about 8th question. Now in question number 8, it is 2 to infinity here. Okay, so within limits 2 to infinity. If I take question number 8 here, this is 2 to infinity dx upon under root, this is x square minus x minus 1. Okay, so if I take, what was this here, 1 upon x if I take, sorry, so it is 1 upon x here. If here 1 upon under root x square minus x minus 1, let me take, this is less than or equal to 1 upon x. Now this is divergent here. So this function is also divergent. 1 upon x is not convergent. Okay. Now out of square root, if I take x out, it will be 1 upon x only. We have to take that this is less or equal to, and by comparison test, but 2 to infinity 1 upon x, it is log 2 will exist. Sorry, it will exist here. Here limits are not 1, but it is 2 to infinity. It will be log x limits 2 to infinity. So its value log 2. Okay, minus log infinity. So this is infinity only. It is not exist. It does not exist here. It is log 2 minus log infinity. Log infinity. So this is infinity here. Does not exist. This is not existing. 1 upon x, integration of 1 upon x, so 2 to infinity 1 upon x dx does not exist. Does not converge, does not converge, or it is not a convergent one. It is, or it is divergent, or it is divergent here. Therefore, this is also divergent function. Hence, Hence, the given function is divergent by comparison test. The given function is divergent because this is not convergent, because this is not convergent by comparison test. This is also not convergent. Okay, so in this way we can say the function is not convergent. Question number 8, not convergent. Now let me talk about the 9th question here. What does question number 9 say? Let me check it. Okay, question number 9 here. It says test the convergence of sin square x upon x square. Okay, it is within limits pi to infinity. Limits pi to infinity. This is sin square x upon x square into dx. Now here n is greater than 2, sorry, equal to 2, greater than 1. It means this function is convergent here. Now here let sin square x, absolute value of sin square x upon x square is less than 1 upon x square. Okay, is less than 1 upon x square, less or equal to, we say, but is less or equal to this. It means this function is convergent. We have to prove that this is convergent. If we prove that this is convergent, here integration pi to infinity 1 upon x square dx is convergent. Why? Well, here n is greater than 1. Here n is greater than 1 or equal to 2. N equal to 2 here. It means this function is convergent from first function. If n is less than is greater than 1, then function is convergent. This is convergent here, or its limit will exist. If I solve it, it will be minus 1 upon x. Okay, if I substitute the limits, 1 upon pi will be there, minus 1 to pi. 1 upon infinity will be 0. 1 upon pi will be there. It is existing. So it means the limits will exist of this. Limit will lie. There will be a limit of this. So this function is integral. It's a bounded function. Hence, is convergent. Therefore, okay, integration pi into infinity sin square x upon x square dx is also convergent. Is also convergent. Why? Let me talk about sin square x is less or equal to 1. Absolute value of sin square x is less or equal to 1. Maybe equal to 1 or is less than 1. Okay, this value. So this value is less than 1 upon x square. Okay. So 1 upon x square is convergent. It means this function is also convergent here. This is what question number 9 is. Now let me talk about 10th question. Now question number 10, this is, we are talking about convergence of improper integrals of first kind. When limits are a to infinity, upper limit is infinity, lower limit is any positive number. Okay, so this is we are talking about. Now 10th question, let me talk. Okay, it is question number 11th here. Sorry, 10th question. 10th question here. Now in this case, we have to find out whether this function is convergent or not. Test 11, sorry, 10th question, 0 to infinity. It is dx upon a square plus x square. Now we have to do this with the mu test. Okay, now here this is within limits. If I write 0 to infinity, it is, if I write here x, if I divide by x square, okay, in the numerator, so it will be x square into 1 upon a square plus x square. Okay, so here n is, here mu is equal to 2, it's greater than 1. If it's greater than 1, then function is convergent. So into dx. Here mu is greater than is equal to 2 or mu is greater than 1. Hence this is convergent. Hence the given function is convergent. The given function, because whenever mu is greater than 1, then it is convergent. If it is less than 1, then it is divergent. Okay. So hence the given function is convergent by mu test. This is with the help of mu test. If I divide by x square multiply, so if I just write this is x raised power mu, mu means 2, mu equal to 2 here. In this case, if I divide then a square divided by x square, this is plus 1. When x tends to infinity, it will be 0. It will be 1 upon 1 only. But in this case, this will be twice x, sorry, x will be, this is equal to 1 then in that situation. This is what convergent function will be, this will be equal to 1. If I solve it, it will be equal to 1. So the function is convergent. The given function is convergent, okay, because mu equal to 2 in this case. This function is convergent. This is why mu test here. So apply the mu test, then we can check mu is equal to, sorry, mu is greater than 2. So mu here is greater than 2. Now let me talk about 11th question. So this is convergent. Okay, now what would 11th question? Let me check that also. The question 11 says that that's the convergence of the function 11. Okay, this is x raised power 3 by 2. So here 11th question. In this case, this is limits a to 11th question is a to infinity, or a to infinity x raised power 3 by 2 divided by what we do here. This is x square plus a square into dx. If I write it as x raised power half into x raised power 3 by 2 divided by x square plus a square. So here mu equal to half, which is less than 1. Here this is dx. Here mu is equal to 1 on 2, which is less than, so mu is less than 1. It means this function is divergent here. So this function is divergent. Now if I divide this by x square numerator denominator, we will get here x square, x square, x square. You have to,